Hi again, everyone. Welcome back. Last week, I started talking about how computer science is relevant to my research. Another field of computer science is machine learning, and I often draw on machine learning for my work too. So very simply put, machine learning is when we have an algorithm that learns something based on data that we give to it. And if we construct the algorithm so that it learns in a similar way as humans do, we can then use the algorithm to better understand how humans learn. Here's one example. Think back to my earlier videos about intuitive knowledge about visuals. In those videos, I talked about how students have to learn to intuitively just see what a visual shows. For example, which chemical molecule a Lewis structure shows, and they have to know this really quickly without even having to think about it. But it's actually very challenging to measure what intuitive knowledge people have. So we could ask them about their knowledge, but that may not actually be the best way to go about it, because if the knowledge is intuitive, people may not be able to verbalize it. Another way is to use eye tracking, but that has its downsides too, because first of all, if somebody looks at something, you don't know what information they actually see in what they look at. But also, you may not actually want to have to bring everybody into your research lab, because that would be very expensive, and also not many of us actually have an eye tracker. So we developed a technique where we show people 3 images, and then we ask them to quickly judge which of the bottom 2 images is more similar to the one on the top. And they don't have to explain why, they don't have to think about these long, they just have to follow their gut instinct to make these similarity judgments. And if we give people several of these tasks in a row, we can then collect a lot of data that we can give to an algorithm, and then the algorithm learns which features drive these similarity judgments. So features like the dots or the lines or the letters. So we did this with about 560 chemistry students, and we found that they most pay attention to the letters. And just to illustrate how this works, we can then map the different molecules that we showed them into a two-dimensional space based on what the algorithm learned, and then we get this. So if you're not a chemist, this may look really messy to you, but we actually asked a chemist, and she could actually make sense of the groupings here, because they actually correspond to different classes of chemical molecules. So that means the way the algorithm learned to group these molecules actually made sense to chemistry experts. But yeah, what I want to illustrate with this example is that we can use algorithms to mimic what students pay attention to when they see visuals without having to ask them to explain what they see. And that is a way that allows us to tap into students' intuitive knowledge about visuals.